After several days of writing out a lot of exponents, you may be excited to learn that there are some rules we can use as shortcuts. Some of you might have actually discovered some of these rules the past few days, and I hope that you have, because they'll make a lot more sense that way. The first rule we're going to talk about, rule number 1, is if I have two bases that are the same, they're both A, and they're being multiplied together, I can add their exponents. Again, if they have the same base and the bases are being multiplied, then I can add their exponents. For example, if I have x cubed times x to the 5th with the same base and they're being multiplied, I can add their exponents. This would be the same as x to the 3 plus 5 or x to the 8th. Now if you'll notice, it's the exact same thing when I wrote it out. Writing out all of those x's also gives me x to the 8th. An example with numbers would be 2 squared times 2 cubed. Because they have the same base and they're being multiplied, this is the same as 2 to the 2 plus 3, which would be the same thing as 2 to the 5th or 32. And again, that's exactly what we got when we wrote it out. When in doubt, write it out to ensure that you're using the rules correctly. Rule number 1, done. Rule number 2, if you have a base raised to an exponent, raised to another exponent, you can multiply those exponents together. Again, if a base is raised to 2 exponents, you can multiply those exponents. For this example right here, we see a base being raised to a power to another power. Our rule number 2 says that I can multiply the exponents, which would be x to the 15th. Now we notice that when we wrote it out, that same thing was true. We wrote out our x cubed 5 times, and we saw that we had 15 x's being multiplied. So a shortcut is to use rule number 2. Rule number 2, done. Rule number 3 says that if I have a quantity or something in parentheses being raised to a power, I can distribute that exponent to each piece of that quantity. Again, if a quantity is raised to an exponent, I can distribute the exponent. AB to the n would be a to the n, b to the n. This is how rule 3 would play out. Notice that I have an entire quantity being raised to a power. I can distribute that power to both things in the parenthesis. Now I notice in the first case with the constant, that would be 3 to the 4th power. For the b, that would be b to the 2 times 4, based on rule number 2. Simplifying, I would get 81 b to the 8th. Now remember, when we wrote it out, we got the same thing. We saw that we had 3 separate b's being multiplied together, or 3 to the 4th, that gave us that 81. And we saw that we had a total of 8 b's being multiplied together, which gave us that b to the 8th. Rule number 3 allows us to shortcut writing out everything. But please remember, when in doubt on the rules, always write it out. Let's put these rules together. Looking at this first example, it does not follow rule number 1. It does not follow rule number 2 or rule number 3. There are no parentheses. This cube right here only applies to this a, and it will not apply to the -3. There is nothing we can do to simplify this. It is just -3 a cubed. These next 2 examples are just regular numbers to powers, nothing specific with rules, but you might be interested to know, maybe you've noticed this after doing a few examples, that if you raise a negative number to a odd power, 1, 3, 5, 7, 9, your answer will stay negative. But if you raise a negative number to an even power, your number will be positive, because each pair of negatives 2, 4, 6, 8 will cancel each other out to make a positive number. Just something interesting to notice. Looking at this next example, we're going to use rule number 3. This cube applies both to the -3 and to the a. So I could simplify that as -3 cubed and a cubed. -3 cubed is -27. So we'd have -27a cubed. Again, the same thing as when we wrote out that -3a 3 times. When in doubt, write it out. For this last one, just remembering always to bring down that negative. It is not part of the parenthesis, so you are not going to square the negative. Using rule number 3, we will apply that squared to each thing in the parenthesis. We would have 3 squared and a squared, which would simplify down to -9a squared. Again, the same thing that we got when we wrote it out. These rules come in especially handy when we're working through really messy problems like these. Let's take a look at this one right here. We're going to start by applying rule number 3 to make sure that this power of 4 gets distributed to each piece and this power of 3 gets distributed to each piece. We notice that when we distribute that 4, we're actually using rule number 2, where we're multiplying the exponents when we are raising a power to a power. Once we have simplified, we get x to the 8th, y to the 12th, 8x to the 6th. Now we're ready to apply rule number 1. We notice that we have an x here and an x here, so we have the same base. They are being multiplied, so we can add their exponents. Instead of saying x to the 8th times x to the 6th, we could say x to the 8 plus 6 or x to the 14th. We will leave our 8 and our y 12th below because there's nothing we can do to simplify. Now please notice that this is exactly the same thing that we got when we wrote it out before, right? We got 8x to the 14th, y to the 12th when we wrote out every piece. And when in doubt, write it out to confirm that you're using these rules correctly. However, when these rules are used correctly, they can save you a lot of time and a lot of writing out. Looking at this next example, we notice that we're going to start first by using rule number 3, where we're going to raise a power to a power. When we distribute this squared term, don't forget to distribute it to the -1 and to the x to the 5th and to the y, and then distribute the cube both to the 2 and to the x. Now be very careful and write out your -1 in parentheses because it will change. Remember, even powers and odd powers for negative numbers will change your final answer. So always write that in parentheses. This would be x to the 5 times 2 using rule number 2 and y squared. And for our second one, it would be 2 to the 3rd power, not 2 times 3, 2 to the 3rd power, and x cubed. Simplifying, we would have a +1, x to the 10th, y squared. 2 cubed is 8, x cubed. Now we are ready to use rule number 1, which says if I have 2 bases that are the same and they're being multiplied together, I can add their exponents. So this would give me x to the 10 plus 3, or x to the 13th, and then I would still have my y squared, and my 1 times 8 would just give me 8. I always write that coefficient in the front. Now let's take a look and see how this compares when we wrote it out. When we wrote out this same problem, notice that we wrote out the 2 3 times, and that's how we got our 8. Notice we wrote down all of our 5 x's for each pair, and our x's here, that's how we got our x to the 13th. So we're doing the same thing when we're using these rules, but we're shortcutting it a little bit, and it's less to write out. You are welcome to use the shortcuts anytime you like on your homework now. However, when in doubt, please write it out, because if you use the shortcuts incorrectly, you will get the wrong answer. Good luck!